Hi guys, so in this video we're going to be going more into differentiation and learning the quotient rule. We're going to be learning how to prove it and also how to use it. So the proof, while not actually necessary for the exam, it would just give you a better understanding of how these formulae have been derived, and then you can use it, which will be necessary in the exam, in future scenarios. So, first of all, when would you use the quotient rule? Well, if we had f of x equals u of x over v of x, where u of x and v of x have terms that contain x within them, so let's say u of x is equal to 3x squared, and v of x is equal to sine of x. Well, since they both have x, we actually have to use the quotient rule in order to evaluate them, since they're in a fraction. So, the next question is, how do we get the quotient rule? Well, I'm going to be proving that now. So let's use the product rule as our basis for this quotient rule proof. So let's say we multiply each side by v of x in this equation to get u of x is equal to f of x times v of x. And now let's differentiate u of x. And since this is a product here, we can actually use the product rule to differentiate this to get f prime, or derivative of f of x times v of x, plus f of x times the derivative of v of x. And now all we have to do is solve for the derivative of f of x, because that's what we're trying to find in the first place. So if we rearrange this, we get u prime of x minus f of x times v prime of x over v of x. So you might think now we're done, but the thing is we're not. Well, what we have to first do before we can complete this is get rid of the f of x. But that's simple enough, really. We want to write this in terms of u of x and v of x only, so we can just substitute u of x over v of x as f of x to get u prime of x minus u of x over v of x times v prime of x over v of x. So, to make this have a common denominator in this numerator part, we can multiply everything by v of x in the numerator to get u prime of x v of x minus u of x v prime of x over v of x, which is also over v of x. And this here actually just gets condensed down to the following expression over v squared of x. And that's the quotient rule. So assuming we have a function that's written as f of x equals u of x over v of x, that function differentiated is equal to the u of x differentiated times v of x minus u of x times v of x differentiated over v squared of x. Let's try out this example over here. So f of x is equal to 3x squared over sine x, where u of x is equal to 3x squared and v of x equals sine x. So first thing we should do is find the derivative of them. So the derivative of u of x is equal to 6x, and the derivative of v of x is equal to cos x. So now let's just substitute that into the quotient rule equation, which we have proved. So first we put u prime of x, which is 6x, multiply that by v of x, which is sine x, minus u of x, which is 3x squared, times v prime of x, which is cos x. And we divide that by v squared x, which is just sine squared x in this case, which gives us 6x sine x minus 3x squared cos x over sine squared x. And we can factor out 3x to get our final answer, which is 3x times 2 sine x minus x cosine of x over sine squared x. So this here is the derivative of the function f of x equals 3x squared over sine x. So let's move on to a slightly more challenging problem to test our knowledge of the quotient rule a bit more. Alright, let's take a look at a slightly harder example. So if f of x equals 7x times ln of 2x minus 1 over 3x squared, find the equation of the tangent to the curve at x equals 1. First thing we should do before we do any actual differentiation is find what f1 is. So the y-coordinate of this function at x equals 1. So f of 1 is equal to 7 times 1 times ln of 2 times 1 minus 1 over 3 times 1 squared, which is equal to 7 times ln of 1 over 3. And since ln of 1 is just 0, then that just becomes 0. So our function here, the point on the curve that we're looking at is 1, 0. So now we just need to find the equation of the tangent, and with that we need differentiation. So to do this, we need to know what the derivative of f of x is. And here, we'll need to use the quotient rule, but also the product rule. So in the numerator, we have two parts that contain x, 7x and ln of 2x minus 1. So we need to use the product rule to be able to evaluate that, and then we can put that in the quotient rule. So let's just do this. So f prime of x is equal to, according to the quotient rule, u prime times v minus v prime times u over v squared. So our u is equal to 7x ln of 2x minus 1, and our v is equal to 3x squared. So our derivative of u is equal to, and then we use the product rule, so 7 ln of 2x minus 1. I'm doing this a bit quickly, but this is just using the same product rule, plus 7x times 2 over 2x minus 1, which is equal to 7 times ln of 2x minus 1 plus 14x over 2x minus 1. We can leave it like that for now. Now we should get on to actually putting that into the equation. So f prime of x is equal to, so u prime first, that becomes 7 ln 2x minus 1. Actually, I'm going to use square brackets here. Plus 14x over 2x minus 1. Multiply that by 3x squared, which is our v. That's subtracted from the derivative of v, which is 6x, times, and then we use square brackets again, 7x ln of 2x minus 1. Now our denominator, our denominator is equal to 3x squared squared. And when we do that, that becomes 9x to the power of 4. And now actually we have our answer. We don't need to simplify this further. All we need to do for this kind of word problem is just insert our value of x in there, and then it'll clean itself up. So the derivative of f of x, where x is equal to 1, is equal to, so we just put 1 in there, that becomes 7 ln 1 plus 14 over 1, because 2 times 1 is 2, minus 1 is 1, times 3 times 1, which is 3, minus 6 times 7 ln 1 over 9, which is equal to, so 7 ln 1 just becomes 0. So that's 14 times 3, which is 42. And then 7 ln 1 again becomes 0, so that last part cancels out, just becomes 42 over 9. And that's equal to 14 over 3. So the gradient, which is the derivative of f of x with x equals 1, is 14 over 3. So the gradient of our tangent is 14 over 3. Now we just need to find the y-intercept. So y, let me write that down. Y is equal to 14 over 3x plus c. So now we just need to find c. So when our value of x, when we have x equals 1, our value of y is 0. So just inserting that into our equation, we get 0 equals 14 over 3 times 1 plus c. So c has to be negative 14 over 3. So our final equation of our tangent is y equals 14 over 3x minus 14 over 3. When we are dealing with the equation of the tangent to the curve 7x ln 2x minus 1 over 3x squared. And we just had to use the quotient rule and the product rule to do this. So thanks so much for watching, and hopefully it helped.